National Data Archive on Child Abuse and Neglect.
Hello, and welcome to the first session of the Learn with NDACAN Office Hour series. This will be a year-long course where people can learn how to code in R. My name is Erin McCauley, and I'm the co-director of the National Data Archive on Child Abuse and Neglect. And Paige Logan, our new graduate research associate, who is a PhD student at the University of California, San Francisco, will be hosting this series. So let's get started.
We are really, really excited to be hosting a very special iteration of the monthly office hours that we do annually. This special iteration will include 30 minutes of training on R for the first half of the session, and then at around 11:30 Eastern time, we will transition over to kind of the regularly scheduled programming office hours, which includes breakout rooms with some of our lovely statisticians and staff at the archive to answer any questions about research design, statistics, working with the data sets, things like that. And I know we have a lot to cover, so just a few very quick reminders, and then I will hand it over to Sarah Cernacker. But we ask that you put questions in the Q&A function in Zoom throughout the presentation. I think the plan is to try to save some time at the end and answer questions as they come in. So feel free to do that as you're listening and as questions come up. This session will be recorded, and all of the recorded sessions will be available on our website. I will put the link in the chat shortly. But if you cannot make it or you want to reference these recordings in the future, everything will be housed on our website and will be available to revisit. And then the last thing is if you have any Zoom issues, please use the link provided on this slide. If you're having a lot of trouble, you can reach out to Andres Arroyo, who is on this call, to answer any issues that you may have. We're really excited to get this started. Our first session is Introduction to R, and I am just going to kick it right over to Sarah to get started.
Thanks, Paige. Hi, everyone. I'm Sarah Cernacker. I'm a statistician with NDACAN. You might have seen my presentations before. So just to reiterate quickly what Paige was saying, this first half hour will be doing instruction and slides, and the second half hour can be as general help with data sets or statistical analysis, or we can talk more about R and the content we go over. So Learn with NDACAN. So this was all put together by me with some help with references that I have links to. So a lot of you here are hopefully trying to learn R and maybe have not used it at all, maybe are familiar with it, or maybe advanced users. And hopefully everyone can get something out of this, maybe even just a new function or different perspective. But why is R useful? Why not Stata or SPSS? Why not SAS or SQL, or what else is out there? M+. R is a really nice entry-level programming language, and it's completely built for statistical computing. And that's similar to SPSS and Stata, very much so. But R is also really nice because it's free. It's open source. It's a big appeal to a lot of people and companies. And when we talk about reproducibility, R is a free tool and a really advanced tool that can do a lot of advanced methodologies very well. And it has a really great state-of-the-art graphics system. So R is, if you're doing any sort of statistical analyses or computing, R is a really great language to get into. Really quickly, some housekeeping. There are materials to go along with this whole course, not just today, but for the whole sequence. There's a box folder that should be publicly accessible with downloadable materials. Data will be released there as we use it in the lessons. So for instance, today we'll be using census level data. if I can get to it, it's in the example anyway, and some exercises. There's documentation for all the code, or sorry, all the data that's provided. So as is the case in anything, regardless of R or not, anytime you have data, you should always refer to the code book to see what the variable definitions are and the category levels. These slides will accompany it. Exercises also, if you're looking just to test yourself and just, yeah, test what you've learned here. I put together examples that hopefully help you do that. And then there will be an example R file along with every week. Additionally, there's a reference that I used sort of lightly putting this together, and it's a book called R in Action, and I actually found it completely online, so the link is right there. And then other useful resources are, R for Data Science, Intro to R, anything you can find online. Every book I find has, a unique perspective and way of looking at data. And yeah, feel free to search the internet freely for more resources. So today, week 1 is an introduction to R. Hopefully today you at least can download and practice running scripts and code. That's the goal. So we're starting very much at the ground level. Data that we'll eventually use in this week's code is census data. So this is population data. I just wanted to put this here for thoroughness and when we go back and reference things. But this is sort of in the weeds. We're using census data, it's population, it's broken down by sex, race, Hispanicity, and that's over a few years. And this is publicly available from CDC Wonder. All of the data, let me say now, all of the data we provide should not be used for research purposes or publication purposes. Some of the data are masked and obfuscated, so they're fake, basically. They're they mimic real data, but they're fake because of all the risks inherent to the data that NDCAN hold, and et cetera, and et cetera. So a lot of the data you'll see, NCANs and AFGARs are knighted. That would have to be directly ordered through NDCAN, but we are making the full research publication data is available through NDCAN. But the data we're using in this class will be in the box folder. This census data, to my point, is data that you can directly get from the CDC. And if you are looking to use population data in your publication, you should refer to that, is my point. So, R. Programming in R. I'm sure you've seen R before if you were here. And when we talk about R, quote unquote, R is actually the programming language that you're using. When you write R code, R is a programming language. That's what the communication from you to the computer is an R programming language. And it's open, fully free, downloadable through what's called CRAN, the Comprehensive R Archive Network. CRAN is referenced a lot because you download R through CRAN, and all of the packages that you would download for R, external and whatnot, live on CRAN. And so you hear the term CRAN thrown around a lot when you use R. There's also RStudio. So RStudio is what, if you are going to program in R, you should open RStudio. You should not open the R that you download as a first step. What you really want to work with is RStudio. And RStudio is what's called a GUI, or a graphical user interface. And what it does is it just makes writing R code so much easier and manageable. And it's just writing in programming R, this R language is like writing in a computer terminal, basically. And RStudio is just, a luxurious place to write your R code and see all your variables and output and all of your graphics in one place. So when we talk about writing R code and using R, and whenever anyone's talking about using R, it's almost synonymously used with RStudio. So how do you get this stuff? If you do not have R on your computer, step 1 is you should download and install the R programming language from CRAN. So I've linked it here. A few things to note. is that you'll have to download for your computer. So like I think you have to download a Mac for a Mac, download the Windows version for Windows, Linux if you have Linux. And I think it automatically recognizes like your default download. I don't think you have to worry about bits or whatnot. So step one, the R programming language. So that's like you're telling your computer, this is the R programming language. Like you're giving it this sort of language dictionary. Then once you have R, download and install RStudio. And this is available through what's called Posit. And I don't know if anyone's familiar. RStudio just used to be available from RStudio. That was like the company, but they've changed into what's called Posit, and it's a whole separate topic. They're like trying to incorporate Python and expand and et cetera, et cetera. But that's where we download RStudio now from Posit. So download RStudio, and then once you've gone through the installation process for RStudio, go ahead and open it. So now you're ready to write your code. And to open a new script, basically a new working document, you click the File button at the top left, where it usually is, New File, and you want to open an R script. And this is like opening a new Word document. Whenever you write a new paper or a new manuscript and you want to close it and then open it later and edit it and this and that, that's what a script is. That's where you write code and programs that you save and send people who you're working with. That's called an R script or a script. So what does RStudio look like? So just really quickly, when you open RStudio, I guess I cropped out the file, but the file drop down should be above here, and that's where you can do new file, script. Also, there's a quick version. This plus sign with a blank will open a new R script for you. So this is what this window will look like. This R script, this is where you would write code and, like I said, write your document, sort of. All of this is green because it's a comment, and we'll get into that, but a comment is using hashtags or pound signs for those born before 2000. Pound signs or hashtags. And so that creates a comment. And so that's not executable code. That's just to leave comments about your code and details about the document, which I cannot emphasize enough how important that is. But that's your R script at the top here. Your R console down here is where stuff will run. So if you run your code, you'll see it pop up down here as a sort of check of like, yep, we're running this, and a warnings and other stuff will pop up here, or it will just complete. And again, we'll get into that, but that's where you see things running. That's where warnings will come up. That's where errors will come up, and you should never ignore those. This is where you can run quick functions, like a help function. Like you don't need to include that in your script necessarily. If you're just, checking stuff out really quick, you can run quick code here. The R environment is where you'll see any saved variables, any data frames, anything that's been executed. So if you open an R script and nothing's in your environment, that means you haven't run your code yet. It doesn't matter that you've just opened your R script. Just looking at the code and you seeing it as a human doesn't do anything until you actually run it. So this is an important button. This is not just writing your code, but running it to tell your computer, go through this code. And so this is where everything will end up, in the R environment. And this is a good check. You'll see you can quickly check dimensions, like how many columns, rows, and etc. And then we have the graphical output and help system. So this is where if you're doing plots or whatnot, or using your help function, this is where it pops up. And you have your help tab, viewer for, actually, I don't know what viewer is, because you have plots for plots, files, you can see the file, the whole tree, the file folder structure. So I'm going to quickly breeze through those because if you're familiar with my presentations, I always run over. So R script, where to write code, R console, where snippets of code can be run, output will appear here. Errors and warnings will appear here in red. I put it in red to startle you and make you note that you should not ignore red text. our environment, executed code, variables, matrices, and then our graphical output. Okay, so programming in R. And I did this very intro level, but I guess I think there's an assumption of some acquaintance with programming and programming topics. And I'm going to touch on what I think are the important things to at least refresh on as you're learning R. But to talk about R functions and packages. So when you're writing R, it has a lot of built-in functions, statistical functions like mean, median, linear models. It can do a lot of stuff. And these are all called base R functions. So if you hear me or anyone refer to base R, this is anything that already exists in R when you download R, like the R programming language. And it has a lot, but it doesn't have everything. I mean, you could probably get by with, I think you could get by, but packages are helpful because packages provide more functions, and they're usually more advanced or niche methodologies that, you know, only a subset of people are using. So it's just not so broad or commonplace that they've included in a base R. Or it could be stuff that expands on what's base R or improves on it. It might just make output prettier, or it might just have better functionality than base R, or it's easier to understand. So there's a whole host of reasons why you'd be installing external packages to accompany base R. And almost every external package you could need exists on CRAN. So like I mentioned, CRAN. And if it exists on CRAN, all you need to do, you don't even have to go to the internet or whatnot. You just do this function from within RStudio, install packages, and then you would put the package name. Because CRAN and R are so intertwined, if it exists on CRAN, you can directly download it. The only caveat I'll say here is some like very niche or like advanced, or I don't know, I guess people who just don't go through the process of CRAN put together R packages and put them on their GitHub pages. And sometimes you have to download it through that. If you're having trouble with that, reach out to me. I didn't put it here. It's like a package. I think you have to use DevTools, the package, and then there's a function. Long story short, I'd be Googling it. So it's very low prevalence of packages that live on GitHub, but when they do live on GitHub, it's just an additional step, really. And I've just listed some examples of very often used external packages: tidyverse, ggplot2, survey if you're using survey data, mice is for imputation, state-of-the-art methodology such as neural net. Yeah. So anything you would want to use, if you're using an external package, you have to install it. And then when you use it in your function and your script, you would include this library package name. You don't need to use install packages every time. You just need to install it once. And you, as your user, usually remember, oh, I've installed that, or R will tell you if you haven't. But all you need to include in your script is this reference to the library. R needs to know, okay, we're using that library, so I know those functions. There's other ways to reference functions within a library, like I've done here, and I use this notation to show using functions and what library they come from if it's not base R. So you don't necessarily need to use this notation, but I definitely use it within slides just to show where external functions are coming from. And that is just to list the library name and then these double colon and function. Okay, so documentation and help. When you're writing programs, use help. I use Google for my code, I think every single day if I'm programming. And I've been using R for, I don't know, like 10 years now or something. So use help. There's package documentation that's available from the CRAN website. There's function documentation, and that's available within RStudio using the help function. And that provides, you know, what input to use in functions, what options are available with functions, how to basically tailor functions to what you need. Any supplemental documentation, just Google. Not just for help and code debugging, But there's also some published articles with more context and examples. And the best example I have of this is Mice has this additional published article that's super helpful and provides a lot of details about the package mice. So if you're stuck, if you're looking for help, use everything. I cannot emphasize that enough. Okay, so quickly going through the next few slides. These are the programming concepts that I'm not going to drill in here, but definitely if something's popping out of like, oh, like I don't know what that is, definitely look into it or reach out to me afterwards. Refresh data types. What's the difference between strings, characters, numeric values versus factor, ordered, logical values? What's the difference between a matrix and a data frame? In R, I'll tell you, a matrix has to be all the same type. And usually you don't work with matrices in data analysis. Usually they come in data frames or tibbles. We'll get into another week. And that's because there's usually different data types across variables, and data frames have nice labels and et cetera, et cetera. Missingness, so NAs, nulls, infinite values, how to assign variables. I'll get to that in a second. There's sort of two ways you can assign variables in R. How to use and access stored variables, conditionals and loops, especially if-else statements. If-else statements come in handy all the time for filtering or mutating or subsetting, all of those things. More stuff, operators, so like really just basic programming. But we use these all the time and they're just like building blocks. So I want to make sure I at least touch on them. Coding style, this is to help you understand your code. This is to help others understand your code. There's basic nomenclature using indents and spaces so your code doesn't look like a garble of words and nonsense. Comments, adding comments, not just for, even if you work alone. I work alone a lot. I add comments for future Sarah because future Sarah needs those comments to understand what the hell past Sarah has done. It's not just for other people, it's for yourself. And then seeking programming help. Google, I use all the time, and that usually takes you right to Stack Overflow. So those two using a lot for help. Okay, quickly. Reading data into R. This is just examples. I'm not going to get into the next few slides too much. It's sort of just examples of functions of how to get started when you're reading data. If you have a CSV file or an Excel file, or if you have data from other programming language, such as Stata, SPSS, it can read in stuff in SAV, DTA, or SAS formats. To do that, you need this external package called Haven. And then quickly, considerations when writing code. This is sort of like the common practices. Conceptualize what you want to do first. So this is not just R, but thinking about what you want to do and writing it down can really help you guide your program and reduce errors. And yeah, so conceptualizing, understand what you can get out of your data. You can be like a dead data set all you want, but it might not have the information that you need to answer your question. And similarly, R might not be the best language for some analyses. There are some complex combination of analyses that I've seen that R is not the best. And like, for instance, M plus comes to mind if we're talking about like, what's a big one? Structural equation modeling always comes back to SEM. Or like, I like survey analysis and Stata because I like the functionality better. So R has limitations. R is great for so many things, but it's good to understand what you can and can't do, not what R, but your data also. Just moving forward, more common considerations, commenting, indenting, using informative names, don't hard code. When writing in R, just common you can split code across multiple lines. You just need to be careful in the way that you do it. This is just an example. For example, this half will not evaluate as you want because it's just going to finish on this line. It's not going to keep going. There's nothing to keep going here. Whereas this is what you would want to put. Code starts 1 plus 2 plus what? And then it goes to the next line. It's like, oh, 3 plus 4. Okay. And then it finishes it up. So this is just when you're writing R code specifically. Additional randomness. R is case sensitive. So cat with a capital C is different than cat with a lowercase c, and all the things with case sensitivity. You can use either this arrow use or arrow dash to assign variables. So X arrow dash 3, let's say, or I really like equal sign. I'm just, to me, it's just like one character versus two. And that's when you can tell I've added to code, because a lot of my colleagues use this one, and then I'll throw in my code and it has all the equal signs. So that's just to say you might see this arrow notation used in a lot of other places to assign variables, or using all over the code. I like to use this here, and they are synonymous. I think there's some very niche issues you can run into, but I've never had that issue. Vectors, this notation coming up with C comes up a lot, and this is sort of, I think it means combine or concatenate more classically. And this is just to show you kind of accessing vectors and whatnot, indexing variables, checking data types, manipulating data. And then the last few slides were just functions, a sort of reference of useful functions as you like explore data. I'm just going to quickly throw up my code, and then we have 4 minutes left, so I take that as a win.
Sorry, Sarah, I was not being a good timekeeper for you.
Oh, that's okay. I saw stuff in the chat and I was like, I hope she's not telling me time's running out. I can't see. This code is available on the box folder. So when you get RStudio up and running, you should open with or to RStudio. So open it with RStudio. Make sure you're not opening R, the R programming language. And you should be able to run through this code. The only thing is, this is my working directory. So this is the only part you should need to change, and everything should work fine. So this is where you would, your folder path to wherever you download our content. And so there's stuff about installing packages, libraries. So once you've installed them, you need to reference them to be able to use them. Basic example of what I mean of assigning variables, using variables. Here, let me just run through this so you can see. So I've opened R. I've run through a lot of stuff. Sorry, I'm like very entrenched in R, so I overlook the small things. So what I've done is, when you are highlighted on a row, I work on a Mac and I do command return, and that will run that line of code. And you can see down here, this is what ran. This showed up down here because I did command return, or you can highlight it and click run. Notice it does the same thing. And it's fine to run stuff multiple times usually. So this is fine. It's just setting it over and over again. So stuff's running down there. And if you do the quick keyboard, so command return, it'll just take you to the next runnable line. So that's why it's sort of jumping down. So I've clicked install packages, and I already have tidyverse. So it's actually telling me it could be updated. I'll do that later. But there's that. Okay, 2 minutes left. I know we will usually leave time for questions, but I think we'll have time for that also in the second half. Just really quickly. So I'm just going through here. Notice I ran this X assigned to 1, and now we see X up here has a value of 1. We can assign Y using X. These are just logical statements. So Y is greater than X, that's true. X is greater than Y, that's false. You can run stuff that doesn't assign to anything and it'll just show up. So it's sometimes helpful just to view stuff quickly. I'm assigning a new variable with my equal sign because that's what I like to use. Just helpful functions that I use. This colon gives you some consecutive numbers. Looking at data types, these are all numbers, these are all strings or characters. Strings are multiple characters, basically. Or characters are rather like words and stuff, and strings are single letters or numbers. Anyway, so just going through, so you can see numbers, strings always have quotes around them. You cannot combine types. The default is to set everything to string. So if you're trying to combine anything with a string, strings will nuke whatever you're trying to combine it. And because what's the other way? Like, how do you convert these strings? You could convert to integer. And that's sometimes useful when you read in data and it didn't read in how you wanted. But if you try to run this, for example, on a string, like it just doesn't make sense. So this is an example of a warning message. It ran, but it was like, hey, like this is stupid. Rethink what you did there. So yeah, this is, then we get to the actual substance stuff. So this is using real data, the census, when you're looking at data sets. Never assume just because your code ran that it did what you want. That's like, I should repeat that every month because that's like the mantra of programming. Just because it ran does not mean it did what you wanted. So this is, I'm reading data to my point, and usually when you read data, you should get to know it and make sure it looks right. So some helpful functions, looking at the names of the columns. This view function will pop it up in a new window. So this is helpful. I will say if your data are really big, the view function may choke a little bit. Head, give you the first view, summary, give you 5-number summary, strings, accessing stuff, indexing data, tables, subsetting, doing the same thing. So showing you that code can be written in numerous ways to accomplish the same thing. And sometimes I find I go back to my code and I'm like, why did I do it that way? And I rewrite the code, which is a waste of time. But there's many ways to write code. And so let me stop talking.
Sarah, we do have one question that came in through the Q&A, so maybe can you see the questions or do you want me to read it?
Read it for the transcript.
Yes.
Oh, right. Okay. So the question is, how do you know if you have the latest version of R or RStudio, and when does it matter if you have the latest version?
That's a great question. When you first open RStudio, every time you open it, doesn't matter how many times you use it, this will be the first text that comes up. I kind of breeze past it because, again, a lot of things I take for granted. This comes up when you open it, and you'll see the version right here, and it'll tell you the date of the version. And they're always named silly things. So this one's Puppy Cup. I've seen like way weirder stuff. And so that will tell you, it honestly does not usually make a difference. I will say package and library versions, that makes more difference. You might find you go to rerun old code and you're referencing a library and you run through your code, and then you get to a point where you see a warning or an error and it's like, oh, this function has been updated, use this one instead, or sometimes it breaks down in unfortunate ways and it needs more touch and go. But so that's where I'd say usually the version of RStudio does not matter so much. I would update it once or twice a year, but like I've gone a long time without updating it. It's more packages, and you'll know when the package is running problems. Like if you encounter problems, that's when you should look at the version of the package. How do you know when packages? So I think that addressed that. I'm just looking at the next question. How do you know what packages are already installed? Also a great question. Usually you just get to know like what's already there, but there is an explicit tab. So in your RStudio, in the bottom right quadrant or whatever, there's a packages tab, and you can see anything that's listed here is installed on your computer. Anything that has a check has been loaded. So you might want a function from this class package, and you can see you have it, but you need to reference the library. So you need to say, okay, R, like we're using this library, for instance, I'll just show you, library class, and I'm going to run it. I don't know if everyone saw, but now we have a check mark. So now R's like, okay, we're going to use class, and it knows those functions. The problem is if you don't load a package and you try to reference a function within that package, R is just going to be like, I don't know that function. And you'll like R will tell you. I will say like a really good thing about R is it's pretty informative in its errors and warnings. It's pretty clear of like, I don't know this variable, or it'll say this is referencing this version, or it'll say variable not found, or sometimes type versions. So
All right. Well, thank you, Sarah, so much for that first session. Now we're going to transition into our regular office hours series.
The National Data Archive on Child Abuse and Neglect is a joint project of Duke University, Cornell University, University of California, San Francisco, and Mathematica. Funding for NDACAN is provided by the Children's Bureau, an office of the Administration for Children and Families.